diskless computer systems on their desktops. This is extremely easy to administer. In the Atlanta public school system, they had 4,400 students, 2,200 thin clients, in 233 classrooms, using 31 servers, but only 4 systems administrators to take care of them. This was a lot of computers to be managed by only 4 people. A lot of people say, I can't afford for my students to have a computer. But here's an alternative. With Linux, you can actually put a complete operating system, the GNU Linux operating system, on a pen drive. And the students can keep their data on that pen drive. They stick the pen drive into an Intel-based computer and they boot it, and they could be using the Linux operating system on that computer. They store their data on the thumb drive and they can take their data with them. There's no licensing worries about this because all of the software is free software. If you're thinking about kindergarten through 12 years, there is a program called K-12 Linux. It is the Linux Terminal Server project plus the Fedora operating system. I'm sorry, the URL is a little light on the slide. I didn't realize that. The GNU Linux program of Extremadura, Spain, has over 500,000 students using the code to learn elementary school subjects. And Poseidon Linux, which was developed right here in Brazil, is a scientific-based distribution in 7 different languages, which talks about geographical information science, 3D visualization, genetics, bioinformatics, and other research projects. All of this code is available for free. In Curitiba, Brazil, not far from here, there was a high school that had no computer systems. And they had no money for computers. So the teacher went to banks and said, give us your computers that you're upgrading. Give us the old ones. And my students will take them apart and reconfigure them and put them back together. And then we will put Linux on them. And they created a computer lab for 0 cost to the taxpayer. But more importantly, the students learned about the hardware of the computer. They learned how to reconfigure them. They learned how to install the software. And from this, they had a pride in what they did that cannot be learned in another way. Let's take a look at a university computer science course. If you want to study operating system design, you can take a look at many different kernels. Not just Linux, but also BSD. It's another Unix-like system. If you would like to show your students what DOS looks like, there's a free copy of DOS with all of the source code called FreeDOS. There's a little operating system called TinyOS that's very, very small. And there's also the Mach operating system from Carnegie Mellon, or the Herd operating system from the Free Software Foundation. And these are not simple toy operating systems. These are complex, sophisticated systems that can do anything that modern-day computer systems need to do. They have a wide range of different file systems that students can study, including Samba, which is a network file system that talks to Windows and also Apple clients. They have almost every networking protocol in existence, but not just the ability to see how the protocol works, the source code to see how it was done. If you're interested in computer security, there are at least 2 different security models that are used in Linux, including one by the National Security Administration of the United States. Virtualization is the key word of today, and Linux has 2 different virtualization methods that you can look at. You can also run some Windows applications in binary-only form on top of our Windows emulator called Wine. If that is not good enough, you can run Windows itself underneath of Box, which is a hardware emulator. But free and open source software isn't just about the operating system. It's about things like compilers and languages. And every language that I know of is a free and open source project where you can study it. The only existing implementation of the Ada language is a free and open source project. If you go out to SourceForge, you'll find out that there are 430,000 different projects out there with 3.4 million developers working on them. Microsoft has 70,000 employees. 28,000 of them are in sales and marketing and therefore have no useful purpose. They only have about 7,000 people whose names have a software engineer. And the programs out there are not just programs for computer science. There's programs out there that help business and enterprise. Programs out there for home and education. Programs out there for science and engineering. And you students can see not only how to use the programs, but how the programs work. They get taught twice. If you want to teach the students how to collaborate to improve the programs, they're taught 3 times. These programs are built on top of other programs, so you can utilize parts of them. If you're doing research, you can do your research faster because you no longer have to write all of the software to do it. And so now we're doing a new type of computer programming. One where we don't create a product anymore, we create a service. A service to the customer of creating software the way they need it. The service that's going to cut that 8.5 billion reais wasted down to perhaps 2 billion reais wasted every day. And if you think we're wasting a lot of money today, imagine when the next 5.3 billion people start using computers. We have to act today. Don't be afraid of the word service, because people who are highly trained to do service can make a lot of money. Think about a brain surgeon. They don't make a product. You do not end up with a second brain when they get finished. They repair the brain you have. And yet we pay them a lot of money because our brains are very important to us. So here's what we should be teaching in this new model. How to do distributed development, how to write and develop to formal standards, how to locate and engage and innovate all the time. This is what we should be teaching. We should not be teaching products. We should be teaching fundamentals so that the things that your university students learn today are good 42 years from today. One of the first speakers here at the conference said, a university student learns something in year 1 and it's obsolete in year 3. I learned things in 1969 that are still just as viable today because I learned fundamentals, not products. It's more than just free software. It's free hardware, like your Arduino or the Raspberry Pi. It's open telephonies. It's open certification, where the community determines what is necessary for people to be certified, and then we develop the certifications for it. We separate training from certification. We allow the students to get the training any way they want to, and then we certify them